Okay, now that we know about slope-intercept form, we can use what we know about slope-intercept form to graph equations without actually making a table of values. So real quick, let's review. Slope-intercept form of an equation is y equals mx plus b, where the constant b is the y-intercept. That is the place where the line will hit the y-axis of the graph of the line, and the coefficient of x, m, is the slope of the line. So now we're going to talk about how to use that information to graph lines. So let's take the equation y equals 2x plus 4. The y-intercept in this case is 4, which I'm going to write as the ordered pair 0, 4, because that is the constant, and it's in slope-intercept form. And the slope is the coefficient of x, which is 2. So now I can graph any line if I know the slope in one point on the line, which I do. So what I'm going to do is I'm going to start at the ordered pair 0, 4, which means I start at the origin and I go up 1, 2, 3, 4, and I'm going to put a dot there. Now, my slope is 2. Let's talk about slope for just a second. My slope is the rise over the run, right? So in this case, it's 2. Well, you have to remember that 2 can be written as 2 over 1. So my rise is 2, and my run is 1, which means that I'm going to go up 2 and to the right 1. Now, if you take a look at what I have here, because my y-intercept is 0, 4, if I were to rise 2 and run 1, I'm going to have a point off the graph. So I got to think about this. Well, remember, going up 2 and to the right 1, the exact opposite of going up and to the right is going down and to the left. Well, why would that make sense? Well, if you think about going down, that would be negative 2. And if you think about going left, that would be negative 1. And since negative 2 over negative 1 is actually equal to positive 2, this is correct as well. It's just the opposite. This would mean that you're going to go down 2 and to the left 1. And in this particular case, that's what I have to do in order to get it on the graph, right? I'm going to go down 2 to the left 1, and I'm going to put a dot right there. And then I'm going to do it again. Go from that dot. I'm going to go down 2 and to the left 1 again, and put another dot. And you can just keep doing that, down 2 and to the left 1, down 2 and to the left 1, until you've gotten as many points as you can on the graph that's given to you. And what you have now is your line. And we didn't even have to make a table of values or really do any math at all to get that. You can, however, every single time you graph a line, you can, however, check an ordered pair to see that it works. And I wouldn't check the y-intercept because usually your y-intercept is right. It's oftentimes that you graph the slope wrong. So let's say I take this ordered pair right here. This ordered pair is negative 1, positive 2. A quick check, and you don't have to write this one down, just pay attention, is to plug in, if I'm checking negative 1, 2, well, I would plug 2 in for y, so my equation is y equals, so I'm going to start with 2 equals. The equation is 2x plus 4, so I'm going to do 2 times x is negative 1 plus 4, and it should work, right? 2 times negative 1 is negative 2, and negative 2 plus 4 is 2. So the ordered pair does work. And if you checked every ordered pair on this line, it would work into the equation y equals 2x plus 4. Let's take a look at the next one. All right, so now this one, the y-intercept is negative 5, or the ordered pair 0, negative 5, because that is the constant. And the slope is the coefficient of x, and notice it has a minus sign in front of it, so it's negative 2/3 x. So, negative 2/3. Let's take a second and think about negative 2/3. Usually the negative sign is written outside on the front or on the top. So, I want to remind you that that negative sign can go on the top, or that negative sign can actually go on the bottom. It's just not in simplest form when it's on the bottom. So if you think about that, both of these answers are negative 2/3. So let's think. If I'm doing a slope of negative 2/3 where the negative sign is on the top, well, that means I'm going to go down 2 and to the right 3. If I'm doing 2 over negative 3, well, that means I'm going to go up 2 and to the left 3, right? It's just the exact opposite. So we are going to start at the ordered pair 0, negative 5. So I'm going to go down 1, 2, 3, 4, 5, and I'm going to start right here and put a dot there because that's where it starts. Now from there, I'm going to graph a slope of negative 2/3. And again, if I do this one, if I try to go down 2 and to the right 3, it would be off the graph. I can put a dot there if I want, but I have to get more dots on the graph. So the opposite of going down and to the right is to go up and to the left. So I'm going to go up 1, 2, to the left 1, 2, 3, and there's where my next point goes. And then I'm going to do it again. I'm going to go up 2, 1, 2, and to the left 3, 1, 2, 3. And in this case, for this graph, only 3 points actually will fit on my graph. And so there's your line. You're going to draw the line. And then let's quickly check an ordered pair. You don't have to write this part down, but it's good to pay attention, right? So this one, this ordered pair is negative 3, negative 3. So if I'm checking the ordered pair, negative 3, negative 3, I'm plugging it in. Negative 3 is y equals negative 5 minus 2/3 times negative 3. Well, think about 2/3 of 3 is just 2, and since it's a negative, and a negative, it's plus 2, right? So negative 3 is equal to 5, negative 5 plus 2. So it does work out. Let's try the next one. All right, now this next one is asking what the y-intercept and the slope is. Remember, the y-intercept is your constant. Now over here, there isn't a constant. There's just variables, right? So think about, could I write plus 0 here? I could, because negative x plus 0 is just negative x. And you have to realize that you're always given things, you're usually given problems in simplest form. So the y-intercept here is the origin. So my y-intercept is going to be 0, 0. So whenever you don't have a constant, that means the y-intercept is 0, 0. And now the slope here is the coefficient of x. And the coefficient of x, remember, would be negative 1 in this case. So my slope is negative 1. So I'm going to start at 0, 0, so I'm putting my starting point at 0, 0, and I'm graphing the slope of negative 1. Remember, negative 1 is written negative 1 over 1. Whenever you're graphing slope, you have to have two numbers to graph, the rise over the run. Also, when it's negative, you have to remember the negative can go on the top, or the negative can go on the bottom. So if I'm graphing this top slope from here, that means I'm going to go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And so I'm going to have a bunch of dots right here. Now, that's enough dots to go ahead and draw your line, but if you wanted to get them all, the opposite of going down and to the right is to go up and to the left, up and to the left. And so here are all the points on my line. If I were to pick an ordered pair off the line and check it, let's say I pick this ordered pair right here. The ordered pair is 2, negative 2, 2, negative 2. If I were to plug that in for y equals negative x, well, negative 2 is y, and x is 2. And since there's a negative sign in front of the x, it works. All right. That's how you graph lines in slope-intercept form. Always start with the y-intercept, and from there, graph the rise over the run, which is your slope.